Hi, welcome to the pre-calculus lecture series. And today in this video, we're going to take a look at the chapter 6 practice tests. Okay, and we're going to go over the several key concepts from the chapter 6, and we're going to work on some practice problems here. Okay, let's go ahead and start it. Okay, and so we'll be able to finish this in this video. Okay, so let's take a look at the first ones here. So the first problem is try to interchange the radians with the degrees and the degrees with the radiances here, right? So we want to change the degrees, 330 degrees to the radians here. So we know the formulas will be the degrees to the radians. You just use your angle times pi over 180. So like here for the 330, so what I do here, I just times the pi over 180, right? So 330 degrees. And then you change that, so you simplify that, and then this will be, if you simplify it, you cancel the zero. So this is 33 pi over 18. So then you do the 11 pi over what? Over 6 radians here, right? Okay, so the key things here is be careful, right? So when you change the degrees to radians, you need to times the pi over 180. So the same things here is 135. So the same thing, I times the pi over 180 here. So if you simplify that, you will get this is negative 3 pi over 4, right? So this is the 3 pi over 4 radians here. So remember, the degrees change to the radian, you times pi over 180. Okay, so now find the degree measurements is from the, the radians to degrees here. So let's see here, this is a 4 pi over 3. So it will just be 4 pi over 3 times what? You have like a 180, okay, to the pi's here. So, right, so this is the formula we have. If you have, the radian, you want to change it to the degrees, you multiply by 180 divided by pi. So here the pi and the pi cancel. So 4, 3, and so what is here? So you have 200 what? 40 degrees, that's right? So the same way, so like for the negative 1.3 radians, so what you do, so you times 180 over pi here, okay? So then you will have the 1.3 times 180, so it's a negative 234 over pi. Then you put it into your calculator, and the pi is 3.1415, right? So you will get a negative 74.48 degrees here, right? So remember that, so you just times 180 to the pi here. Okay, let's take a look, number 3 here. The number 3, they talk about, say, a rotor blade of a helicopter 16 feet long and rotating 120 RPMs, right? So what does RPM mean? That means revolution per minute. So I want to find the angular speed here. Okay, so the angular speed, so let's try to write down the formulas here. The angular speed will just be we call it W's, right? So it will just be what? Will be the total radians times the times over the times, right? So this will be the angle changes, right? So how fast the angle change by time. Okay, so now let's take a look. Right, so the 1 revolutions, we know the 1 revolution is what? 1 revolution is 2 pi. So here I have 120 revolution. It will be equal to what? It will be equal to the 120 times 2 pi will be equal to what? 240 pi radians, right? So it will be 240 pi radians per minute. So now I know my angular velocity will just be how fast the angle change. So it's 240 pi over what? It's over 1 minute here, right? So that's why I have a 440 pi, right? So the radians per minute, this will be my angular velocities here, right? Now the next one here is the linear speed, right? So the linear speed, we said the linear speed, the formula, let's try to write down the formula. Linear speed, we say is V is equal to the S time over T. S is the total distance we travels, right? Okay, so now let's take a look here. We said 1 revolution, that means what? So the circumference of 1 revolution, we say is 2 pi r. So it's 2 pi, then the helicopter roller blade is 16. So this is 32 pi feet, right? Okay, so it's 32 pi feet. And now I did 120 revolution. So the total distance is what? Okay, so the total distance will be 32 pi times what? 120, right? So 32 pi times 120, you're going to get a 3840 pi feet. Okay, and how long it take you to do that? So we said this is the linear speed, is the V, is the total distance. So it's 3840 pi over 1 minute. This is, of course, the units is foot here. So that's why I said it's 3840 pi foot per minute. That will be my linear speed here. Okay, so basically is one is look at the angle change, and the other one is look at the the distance you travel along the circumference. Okay, so now the next things here, we want to find the exact value of that. So the sine 405 degrees here. So like we said, 405. So basically you want to find the reference angle, right? So you turn the whole circle is 360. Then you got another 45, right? So this angles here, so this is, we call it the reference angle is what? This red one is 45, correct? And the black angles here, this black angle is what? It's 405, right? So I know that then the sine 405 is equal to the sine 45 degrees, right? Because it's equal to the reference angle. So the sine 45 is what? The square root of the 2 over what? 2, right? That's from the, the special angles here. Okay, so now the tangent negative 150. So the negative 150, so you can do, we know the tangent, you can have several different ways here. You can find a reference angle, or we know the tangent we talked before is what? Is odd function. So I know the tangent negative 150, you can say is the tangent 150 here, right? So tangent 150, so let's see here, that means 150, right? So you do this ones here. So this is what? This is 150 degrees. So what is the reference angle? The reference angle is here, right? So this is 150. So the reference angle is what? 30 degrees. So the whole thing's here, this one's here will just be equal to the negative. And then the tangent's 150 here, right? So the tangent 150, and so it's in the negative. So here the tangent 150 is equal to the tangent what? 30, right? So the tangent 30 is 1 over square root of the 3 here. Or you can say it's a negative 3 over negative square root of the 3 over 3 if you want to simplify, rationalize your denominators here. So put here so we don't get confused with it. Okay, so it's negative 3 over 3. Okay, let's take a look at second 5 pi over 3 here. So the same way, the 5 pi over 3, So that means you circle all the way to here, right? So this black one is 5 pi over 3. So what is my reference angle? My reference angle is here, right? Okay, so this is my reference angle. So my reference angle is pi over 3. So this one's here, so secant will just be equal to the secant pi over 3, right? And because it's in the fourth quadrant, so secant is positive here. Then the secant is 1 over cosine pi over 3. So 1 over cosine pi over 3 is 1/2. So the whole thing here is 2 here. Okay. Now let's take a look at cosecant 5 pi over 2 here. So it's the same thing here. 5 pi over 2, the whole big circle is 2 pi. So the black start here, right? So that's the black angle. So it's 5 pi over 2. So if it's a 5 pi over 2, then my reference angle is here, right? So it's my reference angle is a pi over 2. Okay, so then the whole thing's here. This is, okay, so this is equal to what? This is equal to the cosecant pi over 2. And also we know the cosecant is a what? Cosecant is 1 over sine pi over 2. So pi over 2 sine is 1, so it's 1 here, right? So all this is kind of like use the reference angle, and then also, use the, the unit circle values here. Okay, so let's take a look at number 5 here. The number 5, it says, find the tangent theta and sine theta using the theta given here. So this is the theta here, right? All right, so we know the tangents, right? So the tangent theta plus sine theta. All right, tangent is opposite of adjacent. So what is here is 2/3, right? Then the sine is opposite over hypotenuse. So here, this is my hypotenuse. It was not given, but then by the Pythagorean theory, I know my hypotenuse here is what? It's the square roots of the square of the two legs. It's 2 square plus 3 square. So it's a 13 here, right? So I know the hypotenuse here is 13. So this sine is opposite over adjacent, opposite over the hypotenuse is 2 over square root of the 13. So if you like, you can take the 2 out. So this is just 1/3, 1 over square root of the 13. There's no need to put it into the calculator and get the decimal. You can just leave the answer like here. All right, so this is kind of pretty simple, just basically use the definition. All right, so then this one's here, they say express the lengths A and B. So I want to find the A and the B, the lengths in terms of the angles, right? All right, so this is my angles here, correct? So this is my angle. All right, so let's take a look at the A, right? So I know the A is the opposite side, right? So I can say sine theta is equal to what? It's A times 24, right? Then you do a cross product, so you can say A is equal to the 24 sine theta. Okay, so for the B's here, so the B is adjacent, so you do the same things. You say the cosine theta is equal to the B over 24, right? So that's pretty easy, right? So B is equal to the 24 cosine theta. Okay, it's pretty straightforward. Okay, now let's take a look at problem number 7. So they say if a cosine is equal to -1/3 and the angle is in the quadrant number 3 here. So let's try to find the tangent theta, cotangent theta plus cosecant theta here. All right. Okay, so now let's take a look at the cosine theta. Right, so if this is the, okay, so let's move this one up a little bit. So here, okay, so the cosine theta, Okay, so here, this is my theta here. Cosine is adjacent over hypotenuse. So I can mark here, this is 1 and this is 3 here. So because cosine, right? So cosine is here, right? So I know the the x here, right, is negative, right? So now by the Pythagorean series here, this is a 3, so this is a what? This is 9 minus 1, so it's the square root of the 8, correct? Okay, so if you want, you can simplify that a little bit. It's 2 square roots of the 2 here. Okay, so now let's take a look here, right? So that this is a quadrant 3. Okay, so the first things I want to find the tangent theta and the cotangent theta plus the cosecant squared, cosecant theta. So the first thing is, of course, you can find the tangent, cotangent, but I know the tangent times the cotangent. This is what? This is identity because the tangent and the cotangent is the reciprocal of each other. So it doesn't matter where the theta is located. So this one is always is 1, correct? Then here, let's say the cosecant theta. So this is 1 plus 1 over sine theta. So I know the sine theta here is the opposite over the adjacent, opposite over the hypotenuse, right? So it's 2 square roots of the 2 over 3 here, correct? All right, but because it's in the quadrant number 3, so what happened to my sign here has to be what? Has to be negative here, right? Because why is this one is negative? It's because it's a what? Quadrant number 3 here. Okay, so now I have my answers here. So this will be the 1 minus, right? So this is 2 square roots of the 2 over 3 over 1, right? So this will just be 1 minus 3, the 2 square roots of the 2. Okay, so be careful, this is the minus here, right? So you can just leave the answer like this. Okay, so that's it. Okay, so now next one's here, we said, okay, if sine, okay, sine theta equal to the 5 over 13, and the tangent theta is equal to the negative 5 over 12, find the secant theta here. Okay, so now you can have several ways. You can do the triangle, or you can say here, you can do this way. You say the tangent theta, you use identity. So the tangent theta is equal to the sine theta over cosine theta, right? Doesn't matter where the theta is. And the tangent theta is negative 5 over 12, and is equal to sine theta is 5 over what? 5 over 13, right? So 5 over 13, and then here, this is the cosine theta, okay? Now you do a cross product. So I know the cosine theta times negative 5 over 12 is equal to 5 over 13. So I can get is cosine theta is equal to what? 5 over 13. And this is 5 over 12. Don't forget this negative signs, right? So this is negative 5 over 13. You flip, so 12 over 5. And boom, boom, 5 cancels, so it's a negative 12 over 13 here, okay? So now we are looking for the secant. The secant theta is just the 1 over what? You see the identity is 1 over cosine. So secant theta will just be the negative 13 over 12. Okay, so it's pretty easy also, right? Okay, let's take a look at number 9 here. We said express the tangent theta in terms of the secant theta, and for the secant theta for the quadrant number 2. See here. Okay, so we use the trig identities here. So one of the trig identity we call it is the Pythagorean identity. So it's 1 of the tangent square theta, 1 plus tangent square theta is equal to the secant square theta, right? Okay, so now you just minus 1, both sides. So what you have here, so you have a tangent square theta is equal to the secant square theta minus 1. All right, now you take the square root, so it's a tangent theta is equal to the square roots of the secant square theta minus 1, or you have negative secant square theta minus 1. See here. Now, in here, I say, hey, the angle is in the quadrant number 2, see here. So, in the quadrant number 2, so tangent is what? Tangent is negative in the quadrant number 2, see here. So, what is my final answer for this one? Then that means I need to choose this ones, right? So I finally say so tangent theta is equal to the negative secant square theta minus 1. All right, okay. So that's a pretty, so all this is just use identity and the definitions here. Okay, so now let's take a look at the problem number 10 here. Okay, so the number 10 here, they tell you the base of ladder, all right, in this picture is 6 feet from the building. So that means here to here is 60 feet. And the angle is 73. So I want to see what is how high up this building is when the ladder touch it, right? So now this is 73. So if I say this is x, so what is the relation of x and 6? I know it's a tangent. So I can say tangent 73 degrees is opposite. So it's x over 6, right? So that means okay, so maybe instead of use x, I should use a height. It's better, right? So I will say this is a height, okay? Then here I will say this is what? I will say this is the height. So the height will just be the 6 times tangent 73 degrees. All right, and then put it into the calculator. And what do you have? So it's 6 times 3.2709. So that means pretty close to 19.63 right feet. All right, that's where it touched the buildings here. All right, so now let's take a look at number 11. Okay, so let's say express the theta in the terms of x's here. All right. Okay, so for here, there are several ways to do that. You can use Pythagorean theory, find the hypotenuse. But in here, this one is easy. I can say, hey, the tangent theta is just what? Is the opposite of adjacent, right? So it's just x over 4. I can do that. Then they want to find the theta. So what do I do here? So I will say arc, right? So I say the inverse x over 4 is equal to what? Equal to my thetas here, right? It's pretty, you can do that. Okay, now for this ones here, theta is over here, right? So here, this is the theta is over here. And then I have x and 3. So the 3 is the adjacent side, correct? Adjacent side to this green angle. And so I can say cosine what theta is equal to the 3 over what? 3 over x here. So then I can take the arc sine. So I can say theta is just arc sine what? 3 over 6. Okay, so it's pretty easy also. All right, now number 12, let's take a look. We say we want to find the exact value of this number, cosine tangent arc 940 here. All right, so the first thing is we need to take care like this one, arc tangent 940. That means what do we need to do here? First, let's draw a triangles here, right? So mark the angle. So I mark here, this is my theta. And so arctangent is 940. So this is 9, this is 40, right? Because it's opposite over adjacent of the theta. And then by the Pythagoras here, so the hypotenuse will just be what? Is the 40 the square plus 9 to the square, right? So I got a 1681. Wow, it's beautiful. It turns out to be a whole number. It's 41 here. All right, so this is the based on this green one. So I know the cosine arctangent 9 over 40 will give me, because the arctangent, so will give me a cosine theta, right? So cosine theta, what is a cosine? Adjacent over hypotenuse. So what is the answer? It's 40 over 41 here, okay? Now let's take a look at some application problems here, all right? So for here, so we want to find the area of the shaded regions, all right? So also I want to find the perimeters of the shaded regions here. Okay, so the areas here, right? So this shaded region. So if I can find the area of this sector, then I minus the area of this triangle, see here, right? Take a look here, this is the triangles, right? So, okay, so if I can find, if I can find the area of this, the whole this sector, right? So if I can find the triangle of this whole sector, see here, I change my yellow to green here, all right? So, okay, so I want to find the area of my sectors here, all right? So first things here, I need to change 32 degrees to the radians. So it's 32 times what? Pi over what? 180. So I will get this is 2 over 5 pi radians. Okay, now we can use the formula we learned that the area of the sector. That means this areas, right? So the area of sector, that means this purple areas here, right? All right, and now I can, okay? So the area of the sector, so if you remember the formula is 1/2 what? R square times the angle. And of course, the angle has to be the radians, right? So this will be 1/2. The R is 10, so it's 10 to the square times 72. We already changed the 72 to a 2 over 5 pi radians here, right? So this is 110. So, okay, so in here we will have a 20 pi, right? So that's what is 20 pi meter square. That's the area. So then I need to find the area of the triangle. Okay. So based on the formula of a triangle, so we say it's 1/2 of the AB sine theta. So AB is just these two radiuses, right? So I can say this is the 1/2 times 10 times 10 times sine 2 over 5 pi is here. So put it into your calculator, you can get this is a 47.55 meter square. So now I know the shaded area will just be 20 pi minus 47.55. Okay, so it will give you 15.28 meters square. Okay. Okay, let's take a look at part B here, the perimeters of the shaded area. The perimeters here, let me erase these ones here. Okay, so the perimeters here include this arc plus this segments here, right? Okay, so now, and also this arc, right? That's what we call it perimeters here. Okay, so let's take a look at the arc length here. What is the formula for the arc length? We say it's R times theta. So R is 10 times 2/5 pi. So we have 4 pi meter, right? 4 pi meter. Okay, so now I'm looking for these ones here, the sectors here, right? So let me switch this triangle to here. So, okay, so maybe this way is easy. So this is 72 degrees, right? Now I'm looking for this ones here, right? So let's put here. And each one's here, this is 10 centimeter, 10 centimeters, right? Okay, so now in order to find the bottom, so I need to find let's try to find the height here, right? So this is the height, right? Okay, so now because this is a 72, so each angle you equally divided. So this is 36 degrees, okay? And then this is the, so I want to find these greens, right? So let's take a look at the half of the green. This is what? This is the x here. X is what? X is the opposite side for the 36 degrees angle. So I can say the sine 36 degree is equal to what? Is equal to x over 10, right? So x equal to 10 times sine 36 degree. So the x here is 5.87785. But remember, I'm looking for the whole things here. So this will be the 2x will be equal to 11.7557, right? Okay, so then I know the total perimeter. So the total perimeter will just be the 4 pi plus 11.7557, right? So if you add that, it will give you 24.322 meter. All right. So this problem is a little hard, but it's really pretty good problem. It's combined a lot of the concept we learned, so, in this chapter, right? So it's pretty, in general, it's pretty good problem. Okay, let's take a look at the problem 14. I want to find this side, right? I want to find what is the x value here. I want to find out what is the x value here, all right? All right, so in order to get that, I have two angles here. So I said, if I can get, okay, if I can get this big side, and then I can also get this side. Then if I use the blue side minus green, red one, I will get the green I'm looking for, right? Okay, so let's take a look here. Let me give I said here, this ones will be, let's say this one is x2, and the small one said this is x1 here. Okay. Okay, so this one, okay, so now let's take a look here. Okay, so let's see here, the sine, okay, so the sine x1, okay, so that's x1 here. I can use this here. So this is, so I said the tangent, right? So I say tangent 20 is equal to x1 over what? 50, right? Opposite of adjacent. All right, so the x1 is equal to the 50 times tangent 20 degrees. Then the same here, this is, I can say here, this will be, okay, so this will be tangent what? 20a is equal to x2 Is the opposite over adjacent again, so it's 50. So I know the x2 is equal to the 50 times tangent 28 degrees. Okay, so now let's put the tangent 20. Let's see what we have here. So let's put the tangent 20 degrees here. So it will be, so this is 50 times 0.39397, 0.36397. Okay, so it's approximately is equal to what? 18.1985. Okay, so the same things here for the tangent 28 degrees. It will be, so this is 50 times 0.531709, then times 50. So here will give you what? This will give you 26.58547. Okay, so what is my x here? X will just be the x2 minus x1, right? Yeah, so just be 26.58547 minus 18.1985. So let's see here, 1985. So this will give you 8 what? 8.38697. 38697. Okay, so that will be the x values we marked there. Okay, that's it. So in general, I think this chapter it's not hard, and the problems is in general are pretty easy. Here we do have a couple problems a little bit harder than the remaining, and I hope this review help. All right, so that's it. Okay, so I hope this will help you to get a good review about the chapter 6, all the key concepts there. All right, that's it. And I guess I will talk to you later. Have a good day. Okay.